Okay, welcome back everyone. The topic for today is categorical logic, and in particular I'm going to be speaking about uh, logic the way that Aristotle thought about it. This is not always something that one goes on to study if one takes classes in logic, but it's a little taste of the sort of formal structure of logic that you will definitely find if you go on to take further courses in this area. So what we want to do is um, we're going to, in effect, create a little language. It's basically English, but we're going to be strict about certain things about syntax, and we're going to basically divide up all assertions into four types of claims, and we will think about how those different types of claims, just based on their syntax or their form, relate to each other. And we will see that this ties directly into the idea of argumentative validity, which we've seen many times before. We can, in effect, use various features about the structure of these claims to make valid arguments. Okay, so let's get started. I've got a few notes here, and I'm going to be referring to this as we go, and I'll be adding to it also. Okay, so we're talking about categorical logic, and a good place to begin is with the notion of categories. So I'm going to go ahead and type a little bit here. Basically, the idea of a category is of a universal term as opposed to some particular name. So, in effect, what we'll be using here are plural nouns. So if you think of any sort of type of thing, any kind of thing, as a noun, that can be a category in this new technical sense. So chairs, tables, students, people, ducks, categorical claims, sentences, guitars, televisions, all of those things are plural nouns, and so all of those things can serve as categories in our new logic that we're building. We will be limiting ourselves to four types of claim, and I'll say a lot more about that in just a second. But I want to say first that each one of our four types of claims will have a subject and a predicate. And the subject and predicate will simply be categories. So the subject term will be one category, the predicate term will be a different category. And the four types of claims, I'm going to actually go ahead and move this down a little bit lower. The four claims will look like this. Some claims will have this form, all S are P. I'm using S and P for subject and predicate, respectively. But remember, those are just categories. Those are just plural nouns. So some of our claims will be things like all students are people, or all dogs are cats, or all guitars are sentences, whatever. No sort of semantic restriction on the terms. Any category that you want to use, you can use. And that goes for all of these four types of claim. Any claim that looks like this, all S or P, is what's called an A claim. Okay? A claims. Pretty easy to remember because A and all go together. Other claims will look like this. No S or P. No dogs or cats. No people are students. And those claims we'll be calling E claims. Third, we will have I claims, and I claims have this form, some S are P. And finally, there are O claims, and those are called, those have this form, some S are not P. Now, these letters as names for these types of claim actually come from an old Latin commentary on this this type of logic that Aristotle built. Obviously, the E and the I and the O are not as easy to remember as the A, and in fact, it's actually just a coincidence that the A goes with the all. These letters come from Latin verbs. The A and the I come from the Latin verb affirmo, which means I affirm. And so you can see that the A and the I are in that word. Affirmo means I affirm. And the E and the O come from the Latin word nego, which means I deny. Right? Think of negate. Right? So you can see how in the first word there's an A and an I, and then the second word there's an E and an O. In fact, the O is just a kind of first-person singular ending, but it's the only other vowel we have in I deny, so we have to sort of need to use it for this type of claim. And the idea is that these claims, the A and the I, are affirmative claims because they're saying that something is true. All S are P, some S are P. Those are both making affirmations. Whereas the E and the O claim are making denials. They're saying of S, in the E case, that none of them is a P. Or, in the case of the O claim, that some of them are not P's. Right? So the E and the O are making negative statements. They're denials, while the A and the I are making affirmative or positive sorts of claim. And so, hence the affirmo for those and the nego for the E and the O. And this is, in fact, what we mean by quality. So quality can be affirmative or negative. Now, the other distinction that is drawn between these four types of claims is a distinction in quantity. And quantity can be either universal or particular. And the idea here is that the A and the E claims have a kind of universal character because they're making a claim not just about some particular thing that happens to be an S, but in effect about all S's. A is quite literally saying that all S's are P, and E is saying that all S's are such that they're not P, right? Or, of course, more standardly and intuitively put, no S are P. Whereas the I and the O claims, by contrast, are merely making claims about some S's, right? They're not making any sort of universal claim. They're making a particular claim. They're making a claim that there is some particular S that's a P, or some particular S that's not a P. And we will understand I claims, some S or P, to be true just so long as there's even one S that's a P. So even if our claim were that some prime numbers are even though there are infinitely many prime numbers that are odd and only one that's even, nevertheless, this will count as true. Okay? And similarly for the O claim, it only takes one S to fail to be a P in order to count this O claim as true. Now, these four claims are standardly put at the corners of a square, much like this one. And the idea is that these four claims bear certain important relations to each other. But before proceeding, I want to emphasize one point, which is that these relationships that govern this square and that obtain between these different types of claim will do so only if the claims in question are corresponding claims. And what that means is simply this. two categorical claims correspond if they have the same subject term and the same predicate term. So for example, all students are people and some students are people correspond, while all students are people and some people are not students do not correspond. Okay, so they have to share the very same subject term, they have to share the very same predicate term. And when they do, then it's meaningful to talk about the relationships that are depicted in this square here. So there's a few different relationships here. As you can see, between the A and the E, there's a relationship called contrary. Between the I and the O, there's a relationship called subcontrary. Between the A and the I, as well as between the E and the O, there's a relationship called subaltern or subalternate. Between the A and the O, there's a relation of contradictory, which also obtains between the I and the E claims. So let's say a word about what these different sorts of claims mean. These different sorts of relationships mean. So first of all, contrary. The interesting fact about contraries is that it cannot be that both are true. Okay, so if, in particular then, if we know that an A claim is true, then its corresponding E claim must be false, and vice versa. Now you have to be careful with this rule. It doesn't say that they can't both be false, and in fact they can both be false. It's not too hard to see that. If we, take a claim like all mammals are dogs, that's clearly false. But of course, it's also false that no mammals are dogs, because some mammals are dogs. So they can both be false, they cannot both be true. And so that licenses this type of inference. If I know that an A claim is true, then its corresponding E claim must be false. Okay? And so that leads to a kind of valid piece of reasoning, right? It's a valid argument if my premise is some A claim is true, and its conclusion is the corresponding E claim is false, right? That has to be a valid piece of reasoning. So for example, premise, all dogs are mammals. Valid conclusion, it's false that no dogs are mammals. Great. Okay, let's go on to contradiction or contradictory. Now the rule for these is that one must be true and the other must be false. Okay, and so again, of course, this leads to a kind of valid inference that we can draw under certain conditions. So for example, if we know that an I claim is false, then its corresponding E claim must be true. and vice versa. If we knew that an E claim was false, then its corresponding I claim would have to be true. Just be careful again about the direction. Of course, here with contradictories, we can be a little more free about it because this is a symmetric relationship. We know that one has to be true and the other has to be false. So if the I claim is false, the E claim must be true. If the I claim is true, the E claim must be false. And similarly for the A and the O claims. Okay. So maybe I'll write that here as well. If we know that an O claim is false or true, either way, then its corresponding A claim must be false, and vice versa. So for example, if I want an example of using this rule of contradiction to produce a valid conclusion, if my premise is something like, oh, I don't know, all humans are mortal beings, then as a conclusion, using the rule of contradiction that I just outlined, emphasize that this is a validly drawn conclusion, right? Well, I'm starting with an A claim. If I want to use the rule of contradiction, then I'm going to end up with an O claim, and I'll be saying in particular that that O claim must be false, right? So then we'll have it's false that some humans are not mortal beings. Of course, whether this premise is true or not, I will leave for someone more intelligent than I to determine. But given this premise is true, this conclusion certainly follows validly. Let's say a word about subalternation. This one is a little bit more complex, but basically what it says is this: if the universal, or let's just say if a universal claim is true, then so must the corresponding particular claim be. And notice the reverse must be true, that if a corresponding particular is false, then the corresponding universal claim must also be false. Okay? So in words, right, if we know, for example, that an E claim is true, then so must the corresponding O claim be. Or if we know that an A claim is true, then so must the corresponding I claim be. Here's an example, and I'll do this one with false instead of true. So truth goes, as it were, from top to bottom down the square. Falsity rises up from the bottom to the top. So for example, if I had a premise something like this, it's false that some lizards are mammals, then a valid conclusion I could derive from that is that it's false that all lizards are mammals. Okay, and that's using the rule of subalternation. After all, if it were true that all lizards are mammals, then by this same rule it would have to follow that some lizards are mammals. But we're starting with the assumption that it's false that some lizards are mammals, and so it follows that it's false that all lizards are mammals. Okay, that's the rule of subalternation. Notice again that these claims must correspond. They must have the same subject term, they must have the same predicate term. And finally, there's the relation of subcontrary. And this one is fairly straightforward. The rule corresponding to this relation is simply that they cannot both be false. Okay? And so in particular, if we know that an I claim is true, if we know that an I claim is false, then its corresponding O claim must be true, and vice versa. But again, be careful of the direction. Just as with contraries, we have to know that one is true in order to use it, right? Because for all we know, they're both false for contraries. So if we know that the A claim is false, nothing follows using the rule of contraries about the status of the E claim. But if we know that one is true, if we know that one is true, then we know that the other must be false. And for subcontraries down here at the bottom of the square, it's just the reverse. Here we have to know that one of them is false in order to use the rule. If we know that an I claim is false, then the corresponding O claim has to be true. And if we know that the O claim is false, then the corresponding I claim has to be true. But if we know that one of these, the I or the O, is true, nothing follows about the status of the other. Because in the case of subcontraries, they both can be true. If we go back to our prime numbers example, well, some prime numbers are even, some prime numbers are not even, and there's no problem there. Both of those things are perfectly well true. Subcontraries can both be true. It's just that they cannot both be false. Okay. This is what this unit is all about. Notice that we can chain these things together, right? So I could use the rule of contraries to draw some valid conclusion, and then I could use some other rule to draw another conclusion, and then I can draw a third conclusion using some other rule, and so on. Okay, and you can get a sense of what it's like to work with the forms of statements and the forms of arguments by doing exercises like that. One thing you might try is just start with some claim like some fish are animals and see which new claims you can derive validly using these rules, just starting with that claim. Great. Now, there's a few more relations that I want to talk about. And these relations are, as I say, off of the square, and that's because these relations do not relate corresponding claims. Okay, so now we're going to think about claims that do not correspond. And even when claims do not correspond, we can still say interesting things about their truth values if they have certain other relationships to each other. And that's what this is about. Now, most of these relationships that we'll talk about next depend on the notion of a complement. And so I want to start with that. Basically, the idea is this. The complement of a category is, I'll just put it like this for now, everything else. Okay? So the idea is, if I have some category like fish, then the complement of the fish category would be non-fish. Now, everything else depends a little bit on what we mean by everything, right? So, for example, if a mathematician says something like prime numbers and non-prime numbers, well, typically we're sort of understanding that the universe he's thinking of, or she's thinking of, is just the universe of numbers, right? And so if I am thinking about the complement of prime numbers in a mathematical context, the complement of prime numbers, generally I probably wouldn't be understanding that to include things like guitars and televisions and telephones. Generally, I would probably take that to mean simply numbers that aren't prime, i.e. composite numbers, possibly including 1. Right, so given certain contexts, we might have some ideas about what everything else might actually mean. If I'm talking about atoms and then I consider the complement of atoms, well, do I mean literally everything else? That would depend on contextual clues. But one thing that you can always do to be safe, if you're not sure about what the opposite or everything else might mean, is just to use the word or the prefix non. Right, so the complement of, let's say, dogs is non-dogs. Okay. Now, if you're in some particular zoological context, then maybe the complement of dogs would be animals that aren't dogs or something like that. But again, if you're not sure and you want to just be very general, you can always safely use non-dogs, right? Because that will capture everything that's not a dog. Notice in particular that a category, together with its complement, constitute everything, right? You take a term and you add it together with its complement and you've got everything. And again, what everything means might depend on context. Okay, so that's the idea of a complement. So now I want to talk about these other relationships. Conversion, let's start with that. Every categorical claim has a converse, and to find the converse of a categorical claim, what you want to do is simply switch subject and predicate. Okay, so for an example, the converse of, let's take an O claim, like some wishes are not horses, is some horses are not wishes. Okay. Now the rule of converses, the rule goes like this. E claims and I claims are equivalent to their converses. And so in particular, if we know that some E claim is true, then so must its converse be. Or if we know that some I claim is true, then so must its converse be. And the same thing for false, right? If we know that some E claim is false, then its converse must also be false. So the thing to be careful of here is that whereas E and I claims are equivalent to their converses and so must have the same, right, have the same truth value as their converses, that's not true for A and O claims. Great. Let's now say a word about obversion. To find the obverse of a categorical claim, okay, 2 steps. Step 1, switch the quality of the claim. Right? So basically what that means is to just slide along horizontally. So if I start with an A claim, move to the corresponding E claim. If I start with an O claim, move to the corresponding I claim. And step 2 is replace the predicate with its complement. Let's do an example. The obverse of some, oh, I don't know, fleas are pests. Now we're starting with an I claim here. So let's move to an O. So we have some fleas are not pests. But now we want to replace pests with its complement, and I'll just use non-pests for that. And so our new categorical claim is that some fleas are not non-pests. Okay. Now, the rule here is a very interesting one, which is that all categorical claims are equivalent to their obverses. Right? So that's a rule that you can always use in an argument. If I start with any sort of categorical claim and I want to draw some valid conclusion from that claim, well, I can always just construct its obverse, and I know that that obverse will be true if the original claim was true. And you can see that this new sentence in our example, some fleas are not non-pests, really does just say the very same thing as some fleas are pests. Right? Because if they're not non-pests, then they must, of course, be pests. Right? If they weren't pests, then they would be non-pests. But what this new transformed version of it says is that they're not non-pests. And finally, we have this rule called contraposition. So to find the contrapositive of a categorical claim, again, 2 steps. First step is switch subject and predicate, just like we were constructing the converse. But then step 2 is replace both categories with their complements. Okay, so here's an example. The contrapositive, well, let's pick an E claim this time. The contrapositive of no games are books is, okay, so we're starting with an E claim, so we need to switch subject and predicate, and then replace both categories with their complements. So switch subject and predicate, no books or games, and then replace both with their complements. No non-books are non-games. Okay? Now again, we want to be able to use this feature of claims, this new type of claim, this new structure for claims in arguments. And so there's again a rule here for using it. And the rule here is that O claims and A claims are equivalent to their contrapositives. And so in particular, if some A claim is true, then so must its contrapositive be. If some A claim is false, then so must its contrapositive be false. If some O claim is true, then so must its contrapositive be. And if some O claim is false, then so must its contrapositive be false. Okay, so again, the thing to remember here is that it's the opposite of what's true for converses. With converses, we have E and I claims being equivalent to their converses, A and O claims not being equivalent. And with contraposition, it's just the reverse. A and O claims are equivalent to their contrapositives, E and I claims are not. Great. So we have now assembled this armory of things to use when we're thinking about arguments in the context of categorical logic. And if we're careful and always follow these rules, then we will be guaranteed of always producing valid conclusions from whatever premises with which we begin. Great. There are lots of examples and exercises in the book, and I encourage you to read over those. And that will do it for today's lecture. Thanks a lot.